So the first thing you need to do then is, under the objective, did we say gradients and circles? I think we called it gradients. Circles and gradients. Oh dear. Okay. Doesn't matter.
So why do you put x squared plus y squared equals 25?
So that's the equation of that circle.
But you've drawn that line to the end of the circle and shook the line through.
So that's a point on the circle. No, that's not the equation of that line. So if you remember, yesterday I reminded you that this rule here, if we use this rule to generate lots of coordinates, we get a circle. Now it's the first time we've seen a function that isn't written as y equals. But all we're expected to do at GCSE is to recognise that this is a circle with the centre at the origin, 0, 0, and a radius of 5, the square root of that number. That's all we're expected to do. And if you remember, at the end of the lesson I'd said, right, so let's imagine we've got a point on this circle. Trust me, that point is on the outside of the circle. 3 minus 4. I mean, you don't need to trust me, we can work it out, can't we? X is 3, y is minus 4. 3 squared is 9, minus 4 squared is 16, 9 and 16 is 25. So I know that point lies on the circle. And my question was, what's the gradient of that line? And that's just about where we got to. And this is about the bishop, isn't it? So we take that line and we turn it into a right angled triangle, which can go either way. I'm doing it there, but I could have done it up here. And I say, okay, what are my two distances? So this is 4, down 4, just be careful. Jack, please. You don't want your bad behaviour to be published on the internet, do you, Jack? So we've got 4 and 3. So using my bishop, I've got 4 over 3. So the gradient of that radius is 4 over 3, and it's downhill, so it's minus 4 over 3. And as the bell was about to go and people were getting all excited about the end of the lesson, I asked a supplementary question of Arthur, and he got it right. I said, okay, what's the gradient of the tangent that touches the circle at that point? And because Arthur remembered that one of the circle angle theorems is that a radius and a tangent are at right angles, he said, right, I know the gradient of that line because I'm in Mr. Cooper's maths gang, and I know that the secret maths gang sign is change the sign and flip the fraction. So we know the gradient of the tangent is 3/4. And tangents are really quite useful to people who are interested in circles, particularly things moving in a circle, like, for example, a spaceship orbiting a planet. Now, to be frank, actually, spaceships don't orbit planets in perfect circles. Okay, let's imagine that it is, because if you want to escape the gravitational pull of the Earth, the way rockets do that is by getting themselves into orbit and then firing their rockets to an extent that will pull them out of the Earth's gravitational pull. And what will happen then is they will head off in the direction of the tangent to the direction they were going at that instant. And of course, if you are flying to the moon, or with Elon Musk flying to Mars, you want to be heading off in the right direction, because space is big. And if you head off in the wrong direction, you're going to get lost. Okay? So this is really important to... so I often say this isn't rocket science. This is actually rocket science. Okay? What I want us to do is I want us to work out the equation of that tangent. Okay? So having got our circle and defined a point on the outside of our circle and worked out the gradient of the tangent at that point, I want to find the equation of that tangent. And those of you who are on the case, please Max, Those who are on the case with your knowledge organisers know that this process is already there in the knowledge organiser. So what we're going to do is we're going to find the equation of the tangent. So we're finding the equation of the tangent. Little noises like that do get picked up, so it's a little bit annoying, isn't it, for those poor friends of ours who are unable to join us. We're going to find the equation of tangent. Now, the first question I want to ask is, what sort of line is the tangent? Is it a straight line, or is it a curvy line? It is a straight line. We know the equation of straight lines can be written in this form, don't we? Where this is the gradient and this is where they cross the y-axis. Well, I've got a straight line here. So I'm going to try and write the equation in this form here. And the method, well, it's a process that we've done several times. We did it very recently, but it's a process that is worth revising. It is a process that requires two bits of information, a gradient and a point. So my first question is, Tommy will answer this question for me. What is the gradient of the tangent? Do we know it?
Yes.
What is it?
3/4.
It is 3/4. We are halfway to solving our problem. Do we know a point that lies on that tangent? Well, yes, we do. It is the point 3 minus 4. We are ready to go with our three-step technique that will turn those two bits of information into a rule that looks like this. So the first thing to note is that I know that any line, any straight line with a gradient of 3/4, its rule will look something like this. I am halfway towards getting the equation that I'm after. It's just such a shame that I can't work out C. If only I had a value of x and y that I could substitute in and use to work out C. Ta-da! Remember, in a coordinate, we call this number the x number and that number the y number. So what I'm going to do is to rewrite this equation, but instead of y, I'm going to write minus 4, and instead of x, I'm going to write 3. And of course, I've got to do 3/4 times that. And I'm going to use that to work out C. Go on, you have a go. You have a go. I'm working too hard today. That's the tangent. That's the line that we're trying to work out the equation of, and we're doing it by firstly working out the radius gradient and using that to work out the tangent gradient. Remember, a tangent is a line that touches a circle at just one point. That's it. So we've got the gradient of that, and we know a point on it. So we've got all the information we need to complete this process. Cool. Now, okay, we've got a fairly unpleasant sum. I've replaced y with minus 4 and x with 3, remembering that 3/4 of x means 3/4 times x. 3/4 times 3, well, it's not a nice number, so I'm just going to write it as 9/4. And let's pretend at this point that we're on a non-calculator paper. Because I could, if I was on a calculator paper, I would just know that to get C on its own, and I'm trying to work out C, aren't I would just take away 9/4. So I do minus 4, take away 9/4. And some of you will be able to do that because you know that 9/4 is 2 1/4. So minus 9, take away 2 1/4 with minus 11 1/4. But the other way to do it is to think of this as minus 16/4. 4 whole ones is 16/4. And you've got minus 16/4, and you're taking away another 9/4, which gives you minus 25/4. I don't mind which way you do it. Anyway, the answer is that C is minus 6 1/4. So I could write that as minus 6 1/4, or I could write it as minus 6.25, or I could write it as 25/4. Doesn't matter. The fact of the matter is that I've now got my answer, the equation of my tangent. I'm going to zoom out a bit. The equation of my tangent is y equals 3/4 of x minus 6 1/4. In whichever way I want to write it. Now what we have here is the definition of a grade 9 question. There are so many steps involved. Firstly, I had to work out the gradient of the radius. I then used that to work out the gradient of the tangent. I then wrote down my 2 key facts and used those 2 key facts to work out the equation of the tangent. And there was a lot of work involved along the way. However, there is no excuse for getting 0 on a question like this, because you should be able to get somewhere along the way, even if it just means drawing a diagram and sketching it roughly accurate. Yes?